In this video, we're going to do a few more limits approaching infinity examples. Okay, so here we have the limit as x approaches infinity of the quantity 2 plus square root of x divided by the quantity 2 minus the square root of x. And you may or may not notice that this has a horizontal asymptote at +1 over -1, because the numerator is +1/2 is the highest power of x, and the denominator is +1/2. And since the degree of the numerator matches the degree of the denominator, we know that the horizontal asymptote is going to occur at the ratio of the leading coefficients. And in this case, that would be +1 over -1. So our answer will be -1. But maybe you didn't notice that. You said, oh gosh, I have to deal with this. I got to go through my long, drawn-out algebraic process for finding limits to infinity. Well, the first thing you might do would be to rewrite this. The limit as x approaches infinity of 2 plus x to the 1/2 over 2 minus x to the 1/2. And because x to the 1/2, that's the highest power of x in the denominator, we're going to divide all of our terms by that. So here now I have the limit as x approaches infinity 2 over x to the 1/2 plus x to the 1/2 over x to the 1/2 divided by 2, again, divide that by x to the 1/2, minus x to the 1/2, again, divided by x to the 1/2. So I took all of my terms and divided them by the highest power of x in the denominator. And this simplifies. I've got the limit as x approaches positive infinity, 2 over x to the 1/2, plus 1 over 2 over x to the 1/2 minus 1. And so if I look at taking infinity and square rooting it and then saying 2 divided by that value, that's still going to be infinitely large. So if we look at plugging infinity in here, right, if we try to evaluate this, we would say 2 over infinity to the 1/2 plus 1 over 2 over infinity to the 1/2 minus 1. Both of those 2 divided by infinities, they go to 0. So I end up with +1 over -1, which is -1. Let's do one more example. So here we're going to find the limit as x approaches negative infinity for this rational function. And I may not immediately be able to tell where the horizontal asymptote is occurring. So what we're going to do, since we're doing a limit to infinity of a rational function, is I'm going to choose the highest power of x, the largest, or maybe you might think the furthest to the right on the number line, the highest power of x in the denominator. In this case, x to the -2 is going to be what I divide by. So this is the same as writing the limit as x approaches negative infinity. I have -4. X, the cube root of x is the same as writing x to the 1/3. I'm going to divide that by x to the -2. We're going to have a really big expression here, so I'm going to kind of throw some parentheses in. I have x to the -2 divided by x to the -2 plus x to the -5 divided by x to the -2. So we need to simplify all of this. Remember, when we are simplifying rational expressions, a quotient of powers, x to the m over x to the n, that's the same as x to the m minus n, right? So that's our property there. So in this situation, we would have the limit as x approaches negative infinity of negative 4, so x to the 1/3 minus negative 2. That's x to the 1/3 plus 2, or plus 6/3. So 1/3 plus 6/3 is going to be x to the 7/3 over x to the negative 2 divided by x to the negative 2, that's just equal to 1, plus, and when we look at this term, we've got negative 5 minus negative 2. Negative 5 minus negative 2, that's negative 5 plus 2. Negative 5 plus 2 is negative 3. So I have x to the negative 3. And negative 3, that's the same as writing 1 over x cubed, right? So this became x to the negative 3, which is the same as 1 over x cubed, which is where we've pulled that in there. All right, so now I know if I were to plug my negative infinity in, negative infinity cubed, it's going to be a very large negative number, but this term is going to go to 0. And 1 plus 0 in my denominator, that's just going to be dividing by 1. So we're going to end up with negative 4, negative infinity to the positive 7/3 over 1 plus 0. 1 plus 0 is just 1. And dividing by 1 goes away. So now we have to think about what we're dealing with here. 7/3. 7/3 is approximately 2.3 repeating. Well, exactly 2.3 repeating. And that's an odd number. So if we raise a negative to an odd power, that's going to remain negative. We've got negative 4 times negative infinity, and a negative times a negative, that would be positive infinity. We don't need to write 4 times infinity because infinity is large, infinitely large, and 4 times that huge number is still just a huge number. So my answer here would be positive infinity. And if we look at this graph, if I were to plug that function into my y equals, we end up with a graph that looks like this after a little bit of careful zooming. So this represents the graph of my function, and we want to find the limit of that function as x approaches negative infinity. And as x goes negatively to the left forever, right? As x is going towards negative infinity, where does my y value go? My y value goes towards positive infinity. Therefore, the answer to that last example is positive infinity. So it's always helpful for you to look at the graph and to feel comfortable creating that graph using your TI calculator and choosing a window or zooming appropriately. You know, I often use zoom 6, which will give us a standard window, zoom 0, which might fit it, and then I'll go and push the window button to change my window to make the graph look as I want it to. So I hope this helps. Again, email me if you have any questions.